guys, welcome to my channel, and here we are to discuss about some insights of especially optics of ICSC class 8. And here we are basically discussing about the ray diagrams of concave and convex, two kinds of lens. As we know, there are two kinds of lenses. One is plane, sorry, not lenses, uh, plane mirror, and another one is spherical mirror. Okay, so spherical mirror and plane mirror, the difference is very easy to understand, that the plane mirror is a plane surface and spherical mirror is a cutting of any kind of sphere. You are cutting a sphere and it is creating a surface. Whether the reflecting surface is inside or outside, it is totally dependent upon uh, whether the mirror is concave or convex. While you are discussing about concave mirror, you can see that, as we know, that cave means inside, and here you can see that the reflecting surface means the reflecting surface is inside. So concave, here actually the cave means, as we know, that den like structure which is basically inside. There inside a lion can live. So here as well, uh, in the ray diagram, you can see that the reflecting surface of a concave mirror is inside the surface, like that. That is, now there are some basic definitions, like pole. You can say that the midpoint is known as pole, and there is a focal point, and there is a center of curvature. Center of curvature is basically nothing but if the lens is a complete sphere, if the sorry, mirror is a complete sphere, then if it is the radius, if this is the radius, then the center is known as the center of curvature, which we are witnessing here as C. So while a ray is going through, so we have to uh, memorize some formulas, like that if the ray is coming from infinite, or if it is coming out from the focus, if it is coming out from the center. So these are rays are coming out. So this is rays coming out. Coming out. And the position of the image. In the other side, we can uh, actually, this one, the position of the image. Just remember that if the rays are coming out from infinite, then the position of the image will be in the focus. Similarly, the vice versa is applicable. If the rays are coming out from the focus, then the position of the image is in the infinite. You can't actually obtain the image. It will be created in the infinite source, and for the center of curvature there will be C. So there are three kinds of formula. Based upon these formulas, we can actually draw the ray diagrams. Understand? So while the rays are coming from infinity, so as we are seeing this formula, that rays coming from infinity, that the position of the image is focus and the vice versa. So rays are coming from infinity, you just draw the ray diagram, is a straight line, is a parallel to the principal axis of the concave mirror, and this actually reflected back to the focus. And here you can get a very extremely diminished and inverted, especially inverted object. So you can remember like that, if it is real image, then it must be inverted. Okay, and if it is virtual, then it must be erect object. So when it is written as real, you can naturally say that it is an inverted object, and if it is virtual, then it will be erect. So you are getting a very diminished and very highly, you can say, diminished and inverted and real, because you can, the real, actually the real image you can obtain it into the screen, like you can see in the cinemas screens. You can obtain those images. Actually the projector is uh, inverted. That is why you can see those inverted images straight, because the projector itself, we are reverse the projectors. So here point is that while it is coming from the infinity, you have to first draw a straight line coming from the infinite source, and it is creating an object in the, similarly in the downward as well, parallel to principal axis, it is creating an image in the focus, and it is very highly diminished, and obviously it is real, and if it is real, then it must be inverted. Understand? Okay. So we are now coming in the next category. According to our category, next category is focus. Okay, we are coming to the focus. Now, while the rays are actually coming out from the focus, so you can see that the rays are actually coming out from the focus. That is the sign. The rays are coming out from the focus, and it is going through the focus. Okay, it is going through the focus, and you can see that they are tends to meet, but they are not actually coincide with each other, but they are tends to meet. So here as well you can obtain a real, and it is obviously inverted because it is real, and you can see an extremely magnified image. Okay, this is the exception. In this case you can get a extremely magnified object. Here we can see that in the torch lights, actually the bulb is placed in the focus, and the the light rays actually coming out from the these bulbs actually reflected through the infinite, and you can see that the rays are coming out from the from a torch, from a torch. Suppose it is a torch and rays are coming and they are tends to meet, but you can't see where they are actually meeting. So it is, you can see this in a torch light. So actually you are from focus, just a straight line, then draw a straight line, then reverse back the straight line. Here as well you can draw a straight line, and it is also reflecting back and reverse back to the, but don't actually coincide these lines. These lines should remain infinite. Okay, so this will be our second case. Now the third case is in the center of curvature. Okay, center of curvature, here actually we can, from the formula we can see that if you are keeping an object in the center of curvature in a concave mirror, so the position of the image is in the C, means center of curvature. So here as well you are just placing an object in the center of curvature, and just draw the ray diagram, and coming from the object, and it is actually creating a same size object. Okay, so in the center of curvature, beyond center of curvature, and after center of curvature, just remember these two things because it is very much important. Beyond center of curvature, beyond C, and after C. Actually beyond C, the image formed is diminished. Just remember that. And after C, it is always uh, small. Sorry. It is actually large after C. and at C it is the same size. So you can see that in the C there is an object. Okay, so rays are coming out from it, just a straight line, and it is reflecting back at the same size. Image is creating here. If it is 5 centimeter, then that should be also 5 centimeter. Okay, there is no there should not be any doubt about it, and this should be as it is inverted, so it is real and equal to the size of the object. At the center of curvature you can see that the real, inverted and equal to the object. Okay, now here from these three formulas we can obtain other two formulas, that is beyond C and after C. So you can write that like that, C infinity to C. Okay, uh, and you can write that between C and focus. So from this formula, here in the place of infinity, it is like rays coming out. The table is rays coming out, and there is the position of the image. Okay, here is the position of the image. The case or the scenario is the same, just in the place of infinity you can write F and C, and the place of C you can write C, because according to the formula infinity will be changed to F and C will be C, and here the C actually remains C and F will be infinity. Okay, I think it is clear. So beyond the center of the curvature, that is the infinity to C, the image will be produced between the F and the C, that is between the focus and the center of the curvature. There is no doubt about it. And beyond the center of the curvature, I said earlier that it will be diminished, and you can see that the rays coming out from the image, that is creating a diminished object. And always make sure that the rays coming out and reflecting back and going through the focus, and it is creating a diminished object. Okay, now the last case, that is the between the focus and the center of the curvature, you can see according to the formula the focus will be turned into infinity and it will be C to infinity, the position of the uh, image. So in between C and F you can see that between focus and the center of curvature, as I said earlier, that the after C the size of the image will be always inverted real and it will be enlarged, or you can say that the bigger than the object. Here as well you can draw the ray diagram, make sure that the rays are going through the F, and the image created here is real, inverted and magnified, means bigger larger than the object. But here is a catch, one exceptional rule, that is in between focus and pole. You have to remember this. If the image is created in between focus and pole, then if the object is placed in between focus and pole, then the image will be created with the other side of the lens, with the back side of the lens, and it will be erect object and it will be virtual, like you are standing in front of a mirror, and it is a virtual image of your you. It is a virtual image of you. You can't actually touch this, you can't touch this, or you can't actually uh, make the image prominent in a screen, just you can see this in a mirror. So here in between focus or and pole, if you keep an object, it will be virtual, it is erect, as we said earlier that virtual means it should be erect. So virtual, erect, and it will be the magnified, highly magnified. Here actually the dentists place the mirror the teeth uh, in between the focus and the pole to get a enlarged uh, image of the teeth. So this will be the fundamentals, and here the rays are coming out. Just make sure that about that the rays are coming from the object, go through the focus actually, and they are not tends to meet actually, as we know that for the virtual images rays don't meet, they are tends to meet like parallel to each other. So this will be the case of concave mirror. Now we are coming to the last part, that is the convex mirror. So always remember that in case of convex mirror, the image formed always virtual and erect. And if you are talking about virtual, similarly there will be an erect object always. And here are two cases. One is image is placed at focus. If image is placed uh, uh, position of an object at infinity, then there will be in the focus, and opposite side at the principal focus you can see that the rays are coming out, and in the focus actually it is creating an object here, the highly diminished object. Okay, so in case of convex mirror, the virtual erect, and you can see that a smaller image you can obtain, like a rear view mirror of your scooty or vehicle. Rear view mirror, you can see that the object are virtual, and obviously virtual means erect, and these are highly diminished, like you are watching the whole landscapes of behind your vehicle. So you have to at first the position of the object is at the infinity, so the image will be formed in the focus. You can see that from the rays are coming in the focus and then again reflecting back, and they don't meet actually. In case of virtual and erect object, the rays doesn't meet. And if you are the position is in between the infinity and the pole, then you can always obtain a virtual erect and diminished. Here the image is highly diminished, but in this case it is diminished but virtual and erect. So according to the ray diagram, you can just uh, draw like that, and just reflecting out, don't meet don't try to meet the reflected rays, because in case of virtual and erect and diminished object, uh, the reflected rays tends to meet but they don't meet. But here one thing to remember, that the incident ray and the reflected ray, the angle of incidence and the angle of reflection at the point of pole where they are creating these angles are equal to each other, means angle I and equals to angle R. Sorry, this will be a smaller. So that is the whole scenario of ray diagram of a concave mirror and convex mirror. If you like this video and one more video, uh, just subscribe and keep learning. Thank you.